Suppose if you want to write a plus b to the power of 9 or a plus b to the power of 20. So this can be expanded with the concept of a binomial theorem. The number of terms in the expansion of a plus b to the power of n is always equal to n plus 1 terms. We know the formula for NCR. NCR is equal to n factorial divided by r into n minus r factorial. Hello dear students, welcome to this session of Discrete Mathematics class. I am Mr. Niranjan, Faculty, Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence. Now in this session I am going to take very important concept, that is binomial theorem, and few examples based on this binomial theorem. Now let us come to the meaning of this binomial theorem. Binomial theorem for a positive integral indices. Now so you know the formula for a plus b whole square and a plus b whole cube. We can easily write a plus b whole square as a square plus b square plus 2ab. Suppose if it is a plus b whole cube, a cube plus b cube plus 3ab into a plus b we can write. So here suppose if the power is greater than 5, 6, 7, if a plus b to the power of 10, a plus b to the power of 20, those simplification can be done with the concept of a binomial theorem. Now let us have a look on the following identities done here. So earlier we have studied a plus b to the power of 0, that is a to any number to the power of 0 is equal to 1, because a plus b is not equal to 0. A plus b to the power of 0 is equal to 1 means a raised to 0 is equal to 1. Now what is a plus b to the power of 1? A plus b to the power of 1 is equal to a plus b itself. Next, a plus b whole square is equal to a square plus 2ab plus b square. A plus b whole cube is a cube plus 3a square b plus 3ab square plus b cube. Suppose if we want to write a plus b to the power of 4, that can be written as a plus b whole cube into a plus b. That is nothing but a to the power of 4 plus 4a cube b plus 6a square b square 4ab cube plus b to the power of 4. Suppose if we want to write a plus b to the power of 9 or a plus b to the power of 20. So this can be expanded with the concept of a binomial theorem. So this can be expanded with the concept of binomial. So therefore, in order to express these quantities, it is very difficult to simplify the repeated factors. So therefore, this can be expanded with the help of a binomial theorem. That is called the binomial theorem. Now let us know regarding binomial theorem for positive integral index. So what is that? In this expansion, we can observe that the total number of terms in the expansion is one more than the index. So the number of terms in the expansion of a plus b to the power of n is always equal to n plus 1 terms. So one term is more than the index power. So the total number of terms, the number of terms in the expansion of a plus b to the power of n is always equal to n plus 1 terms we will get. So for example, in the expansion of a plus b whole square, we will get the number of terms as 2 plus 1 is equal to 3 terms, a square plus b square plus 2ab. That is a plus b, index of this is 2. Therefore, the number of terms we are going to get is 2 plus 1 is equal to 3. Right. Now, similarly, the power of the first quantity a goes on decreasing by 1, whereas the power of the second quantity goes on increases by 1 successively. So, a square plus 2ab plus b square. Here, the first quantity, the power of the quantity a goes on decreasing by 1, whereas the power of the second quantity b increases by 1 in successive terms. In each term of the expansion, the sum of the indices of a and b is same and is equal to the index of a plus b. Now, let us come to the statement. What is the statement for binomial theorem? So, binomial theorem for any positive integer n, just only the statement is there, there is no proof for this. So, the statements, binomials, if n is a positive integer, then the binomial theorem states that a plus b to the power of n is always equal to nc naught a to the power of n plus nc1 a to the power of n minus 1 into b plus nc2 a to the power of n minus 2 into b square plus etc. nc n minus 1 a into b to the power of n minus 1 etc. nc n b to the power of n. So these nc naught, nc1, nc2 etc. ncn are all called as binomial coefficients. NC0, NC1, NC2, etc. NCN are all called as a binomial coefficient. So in general, if a plus b to the power of n is always equal to NC0 a to the power of n plus NC1 a to the power of n minus 1 into b plus NC2 a to the power of n minus 2 into b square, etc. goes on increases. The last term is NCN b to the power of n. So we can also x plus like this. X plus a to the power of n can also be written as after simplification, we are going to get it as x raised to n plus NC1 x to the power of n minus 1 into a. Next NC2 x to the power of n minus 2 into a square plus etc. plus NCR x to the power of n minus r a raised to r plus etc. plus a to the power of n. So this is the expansion of x plus a to the power of n using binomial theorem. So according to binomial theorem, x plus a to the power of n can be written as x raised to n plus NC1 x to the power of n minus 1 into a, NC2 x to the power of n minus 2 into a square, etc. NCR x to the power of n minus r into a to the power of r, etc. a to the power of n. Therefore, the number of terms in the expansion of x plus a to the power of n is always equal to n plus 1 terms. N plus 1 terms are there. X plus a to the power of n will get n plus 1 terms in the expansion of this. Now, here, therefore, this NCR x to the power of n minus r a raised to r is called the general term or nth term in the binomial expansion, denoted as Tn is equal to NCR x to the power of n minus r into a to the power of r. That is NCR x to the power of n minus r a raised to r is called the nth term, denoted as Tn. Nth term or general term in the expansion of x plus a to the power of n is NCR x to the power of n minus r and a to the power of r. This is very important formula. Use it to solve the problems, the nth term, and also to find the coefficients of x constant. We are going to use this NCR x to the power of n minus r into a to the power of r. Very important formula indeed. Let us take an example. Expand x plus a to the power of 6 using binomial theorem. Now we have to expand. This is 5 mark or 6 marks question. Very important. You may expect this type of question. Now let us expand x plus a to the power of 6. So what is n here? N is equal to 6, x is equal to x, and a is equal to a itself. Now according to the binomial theorem, x plus a to the power of 6 can be written as x plus a to the power of 6 is x power 6, because 6c0 is 1, x to the power of 6 plus 6c1 x to the power of 6 minus 1 into a. Next 6c2 x to the power of 6 minus 2 into a square, 6c3 x to the power of 6 minus 3 into a cube. So the next term is after this plus 6c4 x to the power of 6 minus 4 into a to the power of 4 plus next term is 6c5 x to the power of 6 minus 5 a to the power of 5 plus the last term is 6c6 x to the power of 6 minus 6 into a to the power of 6. Now just find out the values of binomial coefficients 6c1, 6c2, 6c3, etc. Now here just we know the formula for NCR. NCR is equal to n factorial divided by r into n minus r factorial. Find out the value of 6c1. 6c1 is always equal to 6 and 6c0, 6c6 is always equal to 1. Now find out the value of 6c2. 6c2 is equal to factorial 6 divided by 2 into 6 minus 2 is factorial 4. That is 6 into 5 into factorial 4 divided by 2 into 1 into factorial 4. These two gets cancelled. 2 3s are, that is equal to 15. So 6c2 is equal to 15. Similarly, find out the value of 6c3. 6c3 is equal to factorial 6 divided by factorial 3 into factorial 3. That is 6 into 5 into 4 divided by 3 into 2 into 1. 3 2s are gets cancelled 6, 5 4s are 20. Now similarly find out the value of 6c4 and 6c5. Now see here, what is 6c4? 6c4 can be written as factorial 6 divided by factorial 4 into 2. This is equal to 6 into 5 divided by 2 into 1. 2 3s are, that's equal to 15. And the last 6c5 is equal to factorial 6 divided by factorial 5 into factorial 1. That's equal to 6. Now, this is how we are going to find out the values of the binomial coefficients. Now, therefore, x plus a to the power of 6 can be written as, substitute the values. So, x raised to 6 plus 6c1, x power 6 plus 6c1 is 6 into x to the power of 6 minus 1 is 5 into a plus 6c2. What is 6c2? 6c2 is 15 into x to the power of 4 into a square plus 6c3. 6c3 is equal to 20 times x cube and a cube plus 6c4. What is 6c4? 6c4 is equal to 15 times x to the power of 2 into a to the power of 4 again plus 6c5. What is 6c5? 6c5 is equal to 6 x to the power of 1 into a to the power of 5 plus 6c6 is 1 into x to the power of 0 into a to the power of 6. So, therefore, the final answer for this is x plus a to the power of 6. X plus a to the power of 6 can be written as x power 6 plus 6 x raised to 5 into a plus 15 x to the power of 4 into a square plus 20 x cube a cube plus 15 x square a to the power of 4 plus 6 x to the power of 1 is 6 x a to the power of 5 plus 1 into x raised to 0 is 1 into 1 is 1 into a to the power of 6 is a to the power of 6. So, this is how we are going to simplify using binomial theorem. See the number of terms according to the statement. The number of terms in the expansion of x plus a to the power of 6 is 6 plus 1 is 7. Check. 1, 2, 3, 4, 5, 6, 7 terms are there. There are 7 terms. And again the value of x goes on decreases. X power 6, x power 5, x power 4, x power 3, x to the power of 2, x raised to 1 and x power 0. The value of x goes on decreases, whereas the value of a goes on increases. A square, a cube, a to the power of 4, a raised to 5 and a to the power of 6. So, the first value, the value of x goes on decreases and the value of a goes on increases, and the number of terms in the expansion of x plus a to the power of 6 is 7 terms. That's it. Okay. Hope you followed. Right. Now, let us take another example. Expand x square plus 3 by x whole to the power of 4 using binomial theorem where x is not equal to 0. So, this is also same as that of the previous problem. Compare this, comparing with x plus a to the power of n is equal to 4 and here x is equal to x square and a is equal to 3 divided by x. Now, using binomial theorem, you can write x square plus 3 by x to the power of 4 can be written as x raised to n is x square whole raised to 4, x raised to n plus nc1 4c1 x to the power of n minus 1 4 minus 1 into a 3 by x plus nc2 4c2 x to the power of n minus 2 into a square plus 4c2 after 4c2 it is 4c3 x to the power of n minus 3 that is 4 minus 3 into 3 by x whole cube plus the last term is 4c4 x to the power of n minus n 4 minus 4 into a to the power of 4. That's it. So, this is x square whole to the power of 4 plus 4c1 x square whole to the power of 4 minus 1 is 3 into 3 by x plus 4c2 x square whole square into 3 by x whole square plus the next term is 4c cube x square whole to the power of 4 minus 1 is 1, this is 4c cube into 3 by x whole cube plus the last term is 4c4 x square whole to the power of 0 into 3 by x whole to the power of 4. Now just find out the value of 4C1, 4C2, 4C4. So 4C1 is equal to 4, 4C2 is equal to factorial 4 divided by factorial 2 into 2. 4 factorial is nothing but 4 into 3 divided by 2 into 1, that's equal to 6. 2 3s are 6. 4C2, 4C3 can be written as factorial 4 divided by factorial 3 into 1, that's equal to 4. And 4C4 is equal to 1, right? Now substitute here. So therefore the given equation x square plus 3 by x whole to the power of 4 can be written as x square whole to the power of 4 is x raised to 8 plus 4C1 is 4 into x to the power of 2 3s are 6, x power 6 into 3 by x, 3 divided by x plus 4C2 is 6 into x square whole square is x to the power of 4, into 3 square is 9 by x square plus 4C3 is 4 into x to the power of 4C3, x square to the power of 1 is x square into this is 3 cube by x cube, 3 3s are 9 3s are 27 divided by x cube plus the last term 4C4 is 1 into x to the power of 0 is 1 again into 3 to the power of 4 by x to the power of 4, that is nothing but 27 into 3 is 81 divided by x to the power of 4. Now simplify this, that's all. The final answer for this is therefore x square plus 3 by x whole to the power of 4 is x raised to 8 plus 1 x and x gets cancelled, 4 3s are 12 x to the power of 5 plus 1 x square term gets cancelled, 9 into 6 x square, multiply this, 9 into 6 54, 1 x square gets cancelled, you will get 1 x square plus multiply 27 into 4. So this is 108, 1 x square gets cancelled, you divided by x, 108 by x plus, so 8 to the power of 1, so that is 81 into 1 is 81 divided by x to the power of 4. These are the values you are going to get, that's it. So see how many number of terms, 1, 2, 3, 4 and 5. So in the expansion of x square plus 3 by x to the power of 4, you will get 4 plus 1 as 5 terms, that's it, okay. This is the simplified answer. Now let us come to the next problem. Application type problem. Expand 98 to the power of 3 using binomial theorem. Very simple. Let us convert this 98 to the power of 3 can also be written as 100 minus 2 whole to the power of 3. Just convert to the powers of 10. So 100 minus 2 is 98. So this is of the form x plus a to the power of n. Here x is equal to 100 and a is equal to minus 2 and n is equal to 3. Now using binomial theorem, x plus a to the power of n can be written as x raised to n plus nc1 x to the power of n minus 1 into a plus nc2 x to the power of n minus 2 into a square, etc. Now here this 100 minus 2 to the power of 3 can be written as x is nothing but 100 to the power of n is 100 cube plus nc1, that is nothing but 3c1, x is 100 to the power of 3 minus 1 into a, here a is minus 2 plus next 3c2 100 to the power of 3 minus 2 into a square minus 2 whole square plus nc3, that is nothing but 3c3 100 to the power of 3 minus 3 into minus 2 whole to the power of 3. That's it. X raised to n plus nc1 x to the power of n minus 1 into a plus nc2 x to the power of n minus 2 into a square plus nc3 x to the power of n minus 3 into a cube. Now just find out the value of 3c1. Since 3c1 is equal to 3 and 3c2 is equal to 3 Again 3C3 is equal to 1. That's it. Okay. Let us simplify this, substitute these values. Therefore, 98 whole cube can be written as, what is the first value? 100 cube, 100 whole cube plus 3C1. What is 3C1? 3C1 is 3 into 100 to the power of 3 into 100 whole square into minus 2 plus 3C2. What is 3C2? 3C2 is 3 into 100, 3 into 100 to the power of 1 into minus 2 square is plus 4 plus 3C3. 3C3 is 1 into 100 to the power of 0 into minus 2 whole cube is minus 8. Now this can be written as, now simplify what is 100 cube, 100 square and 100. That's it. Now simplify this, 100 into 100 into 100, just if you multiply 3 times, you will get 1 followed by 6 zeros plus 3 into 100 square. 100 square means 1 followed by 4 zeros. Okay. Into minus 2 plus 3 into 100 to the power of 1 is 100 into 4. Again this is plus 1 into 100 to the power of 0 is 1 into minus 8. Now this can be written as 1 followed by 6 zeros plus into minus 6 into 1 followed by 4 zeros, that is 10,000 plus 3 fours are 12 into 100 minus 8. So that is equal to 1 followed by 6 zeros, unit 10. So that is 10 lakhs minus 6 into 10,000, that is 60,000 plus 12 into 100 is 1,200 minus 8. Simplify this, that's it, you will get the answer. Okay. So if you simplify this, well, yes, 10 lakhs minus 60,000 plus 1,200 minus 8, the answer you are going to get for this is 941192. That's it. So 9 lakhs 41,192. So the simplified answer for this is, that is 98 to the power of 3 is equal to 9 lakhs 41,192. That's it. So if you want to verify through the calculator, you can verify, multiply 98 3 times, you will get 9 lakhs 41,192. That's it. Okay. Hope you followed. This is one of the application type problem in binomial theorem. Now let us come to the next problem. Expand 1 minus 2x to the power of 5. Same, this is also same as that of x plus a to the power of n. Here n is equal to 5 and x is equal to 1. Let us consider a is equal to minus 2x. So here 1 minus 2x to the power of 5. What is n? X raised to n. What is x we have taken? X is equal to 1. 1 to the power of 5. X raised to n plus nc1 5x 5c1 nc1 x to the power of n minus 1, that is 4. N minus 1 is 4 into a. What is a? Minus 2x plus 5c2 1 to the power of 4, that is 3. 5 minus 2 is 3 and minus 2x whole square plus 5c3 1 to the power of 2 1 square into minus 2x whole cube plus 5c4 1 power 1 into minus 2x whole raised to 4 plus 5c5 1 power 0 minus 2x to the power of 5. That's it. Okay. X raised to n, nc1, nc2, nc3, nc5, etc. X to the power of n minus 1, n minus 2, n minus 3, a square, a cube, a to the power of 5. Now 1 raised to 5 can be written as 1 plus 5c1 is 5 into 1 to the power of 1 is 1 into minus 2x plus 5c2. 5c2 is also equal to, the value of 5c2 is nothing but, you can write 5c2 is factorial 5 divided by factorial 3 into factorial 2, that is 5 into 4 divided by 2 into 1, that's equal to 10. This is 10. 5C2 is 10 into 1 into minus 2 is nothing but minus 2 square is 4x square plus 5C3. Let me write 5C3. 5C3 is equal to factorial 5 divided by factorial 3 into 2 factorial. So this is also same, that's equal to how much we are going to get? The same value, factorial 5 is 5 into 4 divided by 2 into 1, that is 10 we will get. This is also equal to 10. So that is 5C3. 5C3 is 10 into 1 square is 1 into minus 2 whole cube. 2 2s are 4, 4 2s are 8, minus 8x cube. Again 5C4. 5C4 is equal to 5 into 1 into minus 2 to the power of 4. 2 2s are 4, 4 2s are 8 2s are 16. This is plus 16x raised to 4. 5C5 is 1 into 1 power 0 is 1 into minus 2 to the power of 5 is minus 32 x to the power of 5. Simplify this. What is the answer we are going to get for this? Now this is equal to, that is 1 minus 2x to the power of 5 is equal to 1 plus 5 into 2 is minus 10x. Minus 10x, 5 into 1 is 5 to the 10. Again 10 into 1 is 10, 10 into 4x square. Again 10 into 1 is 10 plus 10 into minus 8x cube, minus 8x cube plus this is 5 into 1 is 5, 5 into 16x to the power of 4 plus 1 into 1 into 1 is 1 into minus 32 x raised to 5. Therefore, 1 minus 2x to the power of 5 is equal to minus into plus minus 1 minus 10x plus 10 fours are 40 x square, okay, minus 8 into 10 is 80 x cube, again plus 15 into 6 is 80 again, 80 x to the power of 4 minus 32 x raised to 5. This is the simplified answer. Hope you followed. Okay, that's it. Now let us take next problem. Now let us come to the next problem. Expand 2 by x minus x by 2 whole to the power of 5. Same. Here x is equal to 2 by x and a is equal to minus x by 2 and n is equal to 5. Straight away you will write, so 2 by x minus x by 2 whole to the power of 5. X raised to n. X raised to n is 2 by x whole to the power of 5. X raised to n plus nc1. 5c1 x to the power of n minus 1. 5 minus 1 into a. A is minus x by 2 plus after 5c1 it is 5c2. 2 by x whole to the power of 5 minus 2 into minus x by 2 whole square. Then nc3, that is 5c3, 2 by x whole to the power of 5 minus 3 into minus x by 2 whole cube plus after 5c3 it is 5c4, 2 by x whole to the power of 5 minus 4 into minus x by 2 whole cube plus the last term 5c5, 2 by x to the power of 5 minus 5 into minus 2 by x whole raised to 5. Now just find out the value of 5c1, 5c2, 5c1, 5c2, then 5c3, 5c4 and 5c5. So you know 5c1 is 5, 5c5 is equal to 1. What are the values of 5c2, 5c3 and 5c4? Okay. So you know 5c2 and 5c3 are 10, 5c2 10, 5c3 is also equal to 10. Okay. And 5c4 is equal to 5. That's it. Substitute here. So I'll go to the next page. So therefore 2 by x minus x by 2 whole to the power of 5 can be written as 2 by 5, that is 2 to the power of 5 by x raised to 5 plus nc 5c1 is 5 into 2 by 4 whole to the power of 2 by x whole to the power of 4 into minus x by 2 plus 5c2. 5c2 is 10 into 5c2 is this 10 into 2 by x whole cube into minus x by 2 whole square plus next 5c3 is also 10 into 2 by x whole to the power of 2 into minus x by 2 whole cube plus 5c4. 5c4 is 5 into 2 by x whole to the power of 1 into minus x by 2 whole raised to 4 plus 5c5 is 1 into 2 by x whole raised to 0 into minus x by 2 whole raised to 5. That's it. If you simplify this, 2 to the power of 5, 2 to the power of 5 by x raised to 5 plus 5 into 2 to the power of 4 by x to the power of 4 into minus x by 2 plus 10 into this is 2 cube by x cube into minus x square, minus into minus plus x square divided by 2 square plus 10 into 2 square divided by x square into 2 square by x square into minus x cube divided by 2 cube plus 5 into 2 by x into this is minus into minus plus x raised to 4 divided by 2 to the power of 4. Again this is 1 plus 1 into 1 into minus x to the power of 5 divided by 2 to the power of 5. Simplify this. So, therefore, the simplified answer 2 by x minus x by 2 whole to the power of 5 is equal to 2 to the power of 5 means 32 divided by x raised to 5. Again this is minus 1 x and x gets cancelled, 2 gets cancelled, 5 into 2 cube, 2 2s are 4, 4 2s are 8. 8 into 5 is minus 40 divided by x cube. Okay, minus 40 divided by x cube plus here 1 x square and x square gets cancelled, 1 2 square gets cancelled, 2 10 into 2 is 20, this is plus 20 divided by 1 x square and x square gets cancelled, you will get 1 x in the denominator. So, if you come to this, what happens? Minus 1 x square terms gets cancelled, 1 2 square gets cancelled. So, in the numerator we will have 10x divided by in the denominator is 2, 10 by 2, 10x by 2 and here plus 5, yes, 2 to the power of 1 2 x gets cancelled, 1 x gets cancelled, 5x cube divided by in the denominator 2 cube, 2 2s are 4, 4 2s are 8 and the last term is minus x to the power of 5 divided by 2 into 2 into 2 into 2 2s are 4, 4 2s are 8, 8 16, 16 2s are 32. That's it. So, this is the simplified answer. That's it. Hope you followed. Okay. So, if you want, you can simplify. 2 5s are 10. So, 32 by x raised to 5 minus 40 by x cube plus 20 by x minus 5x. 10 by 2 is 5x plus 5 by 8 x cube minus 1 by 32 x to the power of 5. That's it. This is how we are going to simplify. Hope you followed. Now, that's all regarding this session. Hope you followed how to expand using binomial theorem where n is a positive integer. So, that's all regarding this session. Let us meet with a few more problems in binomial theorem in the next session. Thank you very much.